Welcome to another of my videos where I work through and explain A-level multi-choice questions. If you want to try this question yourself, pause the video now. If you came up with the answer D, give yourself a pat on the back. If you want to see my explanation of how I found the answer, please continue watching. So, a narrow beam of monochromatic light is incident normally to a diffraction grating. The first order diffracted beam makes an angle of 20 degrees with the normal to the grating. What is the highest order visible with this grating at this wavelength? So we've got a diffraction grating. The separation of those slits is given by D, and that will project onto a screen. We will see various maxima. One straight through is called the nth order, N0, and we have the first order, N1, N2, etc. And these various orders make an angle theta with the normal line. Now, in theory, we can get orders going all the way around. In theory, we'll eventually get orders that where the angle theta is greater than 90 degrees, and that isn't visible, it's not even possible, because that light hasn't been diffracted by the grating. So in order to find this question, what we need to do is we need to find the nth order that would be at 90 degrees. That's not going to be a whole number, and then we need to find the whole number that's slightly less than that nth order at 90 degrees to find the last possible value, last nth order that is actually visible. So I'm going to use the equation D, which is the slit separation, multiplied by sine theta, which is this angle between the 0 and the nth order maxima. There's n, which is the nth order, and lambda, which is the wavelength. Now we've got a problem. We're not told the wavelength, and we're not told the slit separation. But we do know that the wavelength of the slit separation is going to be constant. So I could rearrange that equation and say that D over lambda is equal to n over sine theta. And because D over lambda is going to be constant throughout this question, n over lambda is going to be constant throughout the question. So the nth order, to start with, it's a first order, so n is 1, and sine theta, or theta, is 20. So we get a value of 5.85. So now we want to use this ratio of D over lambda to find the highest order visible through this grating. So let's write the equation out again. D sine theta equals n lambda. And remember, what we want to do is we want to find the nth order when theta is at 90 degrees. So if I make n the subject of this equation, n is equal to D over lambda sine theta. Now D over lambda doesn't change during this equation, during this question. And we established over here that D over lambda is 5.85. So n is equal to 5.85 sine theta. Sorry, sine 90 degrees. Sine of 90 degrees is 1. So n is equal to 5.85. That means that at 90 degrees, the nth order would be 5.85. Well, you can't have a value that isn't a whole number. So the actual visible nth order, the last one visible, is going to be a value of 5, just less than 90 degrees. So the answer is B. I hope you found this useful. If you did, please like and leave a comment below, and I'll hope you watch more in the series.